Hey guys, today we're going to be starting Chapter 11, which is going to be about finding the volume of figures. So we just came off of our area chapter, and actually everything you did in area is going to be very important here because it forms a large part of finding the volume of a solid as well. So today we're not going to get into any computations. Really our goal for today is to be able to understand and identify some key vocabulary terms, and then really to be able to identify and name certain solids. So we'll get to that in a minute. Right now we're just going to run through some vocabulary that we have to have. Okay, so first we're going to talk about what we mean when we say solids, right? And really what we're talking about is three-dimensional figures. Okay, so three-dimensional figures, or solids, can be made up of flat or curved surfaces. Okay, each flat surface is called a face. So in other words, if I were to look at this solid here, you can see one of the faces is named. So essentially I have two faces that are parallel, one on top and one on bottom, and then I have each of the four faces that makes up the sides. So this figure here would have 6 faces. Again, they're just the flat surfaces. Okay, so an edge is the segment that is the intersection of two faces. Okay, and so again here's an edge, right? And we could go around and we could highlight all of those edges. So I have 1, 2, 3, 4 edges there, then 5, 6, 7, 8, and 9, 10, 11, 12. So I have 12 edges. Again, those are just where those faces intersect. And then last we have what we call the vertex. Right? And a vertex is just a point that's the intersection of 3 or more faces. So sometimes I think of the vertices as those kind of the corners. So here would be a vertex. So I have 1, 2, 3, 4, 5, 6, 7, and 8. So 8 vertices in that case. And now we're not going to be asking you to count these up, but it's just important that you can recognize the vocabulary and know what it means. So that's the basic vocabulary we'll be using when we talk about solids. Now we're going to talk about different categories of solids, and the first one are going to be our prisms. Okay, prisms are going to be formed by two parallel and congruent polygonal faces called bases. Now, the key here is that our bases are also going to be, or are always going to be, the figures that are congruent and parallel. So for example, when I look at this figure here, I have a bunch of different faces. However, these two, the one on top and the one on the bottom, are the only two that are both congruent and parallel. So that's how I pick out the base of a prism. Now, this one happens to be sitting on its base. That won't always be the case. So again, we're focusing on finding the parallel and congruent shapes in that prism. Okay, and those bases are going to be connected by faces that are parallelograms. So you can see here, at the front of my prism, I have a parallelogram, and then back these two sides, those would also be parallelograms. So that's one kind of category of geometric solids. The next one, which I'm sure we're all familiar with, are cylinders. These are like our soup cans. Okay, so now these are formed by two parallel and congruent circular bases. Right, so in this case, the shapes that are parallel and congruent happen to be circles. And again, this happens to be sitting on its base, but we could imagine one that is maybe rotated like this. right? And these would still be our bases because they're the parallel and congruent faces. Okay. Now here we have our circular bases, and here we happen to have a curved surface that connects the bases. So that's what we meant up here. We said that there are three-dimensional figures that can be made up of flat or curved surfaces. So in our prisms, they're all going to be flat surfaces, but then our cylinder, we have our curved surfaces. Okay, now we have our pyramids. And the big thing here is that pyramids are going to come to a point. So they make them really easy to recognize. And again, when we start finding the volume, that difference is going to be very important. So pyramids are going to come to a point. Okay, so now these have a polygon that's a base, so formed by a polygonal base. And these have triangular faces that meet at a common vertex. So whereas in our prisms, all of our bases were parallelograms here, now we're going to have bases that are faces that are triangles. Okay, and now pyramids are going to be named for the shape of their base. So here, I can see my base in this pyramid actually happens to be a triangle here. So I would call this a triangular pyramid. Again, seems very obvious, but key here is that our pyramids are going to come to a single point, whereas our prisms do not. All right, on the next page here, now we have cones. Again, you guys are familiar with these. Think of ice cream cones or traffic cones, right? These, again, are going to have a circular base, so that base is a circle, and a curved surface that connects the base to a vertex. So I think those are also very easily identifiable. Okay, and then the last one is just a cube. This is really a specialized prism. So it still is a prism. Okay, and this is just a prism that has 6 square faces. So even though it's not specifically indicated here, all that means is all of these sides would be congruent in order to be a cube. So at this point in time, really the important thing for us to be able to do is to be able to determine whether a solid is a prism, cylinder, pyramid, or cone, and then for those prisms and pyramids, be able to name them by the shape of their bases. Right? So our prisms and pyramids are named for the shape of their bases. And so we're going to do a little practice with that here in the notes, and then you guys will have a chance to do Quiz Quiz Trade tomorrow, so you'll get to see a lot of different figures and make sure that you're able to name them correctly. So we're going to go through here and look at these. Now, these are all going to be prisms and pyramids. Again, the cylinders and cones are pretty easy to identify. These are where it tends to be a little trickier. So I'm going to start here. The first thing I always think of is I ask myself whether this is a prism or a pyramid. Now, for this, it's pretty clear to see that's not coming to a single point anywhere, so I know that it's a prism. Now again, I have to name this by the shape of its base. And remember, we said there are really 2 kind of things I need to look for here. The base is going to be a pair of polygons that are both parallel and congruent. So as I'm looking here, these parallelograms here obviously are not going to be parallel because they're intersecting. So in this case, my bases are going to be these triangles. I have one down here. Again, it just happens to be the one that it's sitting on. And then one up here. So in this case, I would name this a triangular prism. Now, the next one, again, I don't see it coming to a point anywhere, so I know it's a prism. Now, this one we actually have some leeway in what we call the bases, right? We could consider these shapes, the top here and the bottom. Those are obviously going to be parallel and congruent. They're never going to intersect, and they have the same size and shape. So I know this is going to be a rectangular prism. Now, in this case, you may have actually looked at this and picked up, let's see if I can get a different color. We could also consider this face is going to be parallel and congruent to this face. So we could have called that the base as well. So for a rectangular prism, it's a little arbitrary which one you call the bases, as long as you identify the correct pair. But either way, we would name it the same. It would still be a rectangular prism, regardless of which pair of bases we chose. Okay, again, I'm noticing a pattern here. The top row, nothing's coming to a point. These are all prisms. And again, I'm always going back to picking out what are the parallel and congruent shapes. So obviously none of these around the sides, those aren't going to be parallel. So I have to look here. It looks like 1, 2, 3, 4, 5. Looks like I have a pentagon here. And then also at the top here, 1, 2, 3, 4, 5. These are my bases. So this is a pentagonal prism. And then last but not least, 2, 3, 4, 5, 6. Here I have a hexagon. And a hexagon on top as well. Those are our bases. So hexagonal prism. All right, now, pretty distinctive on the bottom are our pyramids, because they're going to come to a point here. So these are all pyramids. And actually, in each case, they're going to have the same base as the figure above. These just happen to be pyramids because they come to that point. So again, this base here, right? And I can find the base opposite that vertex, that point, so I know my base is opposite. And so this is a triangular pyramid. Okay, going down the line, right? Here's my vertex. Opposite that vertex, I have 4 right angles here. So I know I have a rectangle. So I'm going to have a rectangular pyramid. Next one, I have 3. Yep, this is again my pentagon. So pentagonal pyramid. And then last but not least, here is our hexagonal base. So we're going to have a hexagonal pyramid. So that's what really we need to be able to do for today. Obviously, we're going to need to be able to identify and name them if we're going to be able to apply the correct formulas for their volumes. So tomorrow we'll get more practice again just to ensure we're really good with identifying those prisms. So that's it for today, and I'll see you in class tomorrow.